Okay, so let's try another one. Oh, I guess I should just say from the last problem that you might be asking yourself, for when we got an answer in the last problem that the series converged for all values between -1 and 1, you might be saying, what does it converge to? And the answer at this point is we don't really care. Just like with infinite power series, we often just care, did it converge or not? So the way you want to be thinking about that answer is that if you were to substitute any value between -1 and 1 into that original power series, then you would get a convergent series. And that's really the way you want to think about it for right now. So that's really what we're doing. So let's look at the next problem. Sorry, that's a crazy sigma. What does that say? 2n minus 1 over 2n minus 1. Sorry, I saw that the camera is losing focus every once in a while. So hopefully that'll be fine. Okay, so again we have an alternating series. Let's apply the ratio test. So I'm going to again ignore the alternating part. When we replace n with n plus 1, so remember we've talked about this in class, when the n gets replaced with n plus 1, the 2 is going to distribute in. So it's really going to be, so 2 times n plus 1 minus 1. It's going to be 2n plus 2 minus 1. So, wow, my brain's in a fog. 2 minus 1 is 1. So it's going to be 2n plus 1 over 2n plus 1. And then when we flip and multiply, x to the 2n minus 1 the x to the 2n's cancel. The x to the -1 can come upstairs and join the other x to become x squared in the numerator. And so as the limit as n goes to infinity, again, you want to be thinking about the x squared is not really being part of the limit. So we're just looking at the ratio of these two things. These are both polynomials of first degree. And so it's just going to equal, this part's just going to equal their leading coefficients, which is 2 over 2. So in other words, that cancels, and we're just left with x squared. Now the absolute value and the squaring is sort of redundant, so you can just drop it here because anything squared is always going to be positive. So again, we're in basically the same scenario where we're just looking for where is this thing going to converge. So this will converge absolutely if x squared is less than 1. So what values are those? Well, if you think about this as saying the same thing as all values between -1 and 1, right? So we know it converges absolutely. In that case, we know it diverges. Wow, sorry, that's really messy. If x squared is greater than 1. And then again, we've got this inconclusive where x squared is equal to 1, or again, those endpoints plus or minus 1. So again, we have to check the endpoints. Now the endpoints aren't always going to be plus or minus 1, so this was probably a bad first two examples because they both work out the same way in terms of the values of x. But let's see what happens now when we substitute 1 and -1 in. So when I want to check my endpoints, let's first start with, let's let x equal -1. Okay, so we've got negative 1 to the n minus 1 times negative 1 to the 2n minus 1. So those are both negative 1s in the base, so we want to combine them. Let me dry this. So when I add the exponents, I get n minus 1 plus 2n minus 1 is 3n minus 2. All right, what do I know about negative 1 to the 3n minus 2? Well, it's still alternating, right? Because 3 times n is going to be, when it's going to sometimes be even and sometimes be odd, right? Like if n is an even number, then 3 times it stays even. If n is an odd number, then 3 times it stays odd. So sometimes it's even, sometimes it's odd, and then when I subtract 2 from it, obviously it stays even or odd. So I've got an alternating series. So again, you could try the alternating series test, which I would encourage you to do. Maybe pause the video for a second. And when you do, hopefully you find again that this thing converges. So this converges by the alternating series test. Again, it converges conditionally, I believe, if you want to do the whole problem out. Now let's let x equal 1. So that would be the series negative 1 to the n minus 1. And then this part would just become 1 to the 2n minus 1. So that's just 1. So in fact, we have basically the same series, because this is again alternating. And more classically, it's alternating. And so again, alternating series test would say it converges. So this one, the values for which it converges are between negative 1 and 1. Okay, so not terribly different from the last problem. But again, the way you want to think about this is if you pick any value between negative 1 and 1 and substitute it for your x here, the result will be a convergent series. If you pick any number outside that interval and replace it with x, you're going to get a divergent series. And so that's what we're really finding. We're finding all the values of x that make it converge. And so those are those values.